Hi there, my name is Fadi El-Rukby. The objective of this four-part series is to present to you an end-to-end demo of a system that combines a number of the technologies that are typically used in real-life scenarios by big data teams and data science teams. This is the agenda for the first episode. I'll give you a second to have a look at it. Now, this is an overview of the four-part series. And as you can see, in the first, there are a lot of technologies, and we will show how they all will work together. In the first part, there is an ASP.NET MVC application that is a website for a book club. That website has a MongoDB database in the cloud, and then we use Flume to stream data from the weblog of the website into SOLR, and then we integrate that with into Hbase, and we integrate that with SOLR. And the purpose of that is to overcome some of the limitations of Hbase, and then I'll demo to you how to use Impala to query Hbase tables, and we'll have a look at the Hbase interface in Hue, which is part of the Cloudera's distribution of Hadoop, and then we'll have a look at how we can leverage the REST APIs for both SOLR and Hbase to integrate them and use them within a Python program to get the data that you want based on the criteria that we have. And then in part 2, we continue with more data acquisition, because that's a really big part of what data scientists have to do their work. So there is screen scraping of an online book site. There is also getting databases, like MySQL database, where there is more comments and ratings for books. And then we will use all the data that we have, to build a model to implement sentiment analysis on Twitter API, where we will get tweets on books by people who have read books and then tweeted about them, and then we'll try to implement the sentiment analysis model on that to figure out whether these tweets are positive or not, or to figure out the rating. And the idea is that this way we are enriching the data that we already have. And then in part 3 we'll talk about Lambda architecture, which addresses an aspect of combining both batch operation and more near real-time calculations together, and presenting a unified interface. And for that, as far as technology, we'll use Spark for doing real-time stream analysis, and then we will build a recommendation engine using Mahout, and we'll have a discussion a little bit about Pearson's correlation, naive Bayes, logistic regression. Now, once we have a system, then we want to take advantage of the cloud, so we'll talk about Amazon Web Services and maybe Azure, how we deploy the system there. And then in part 4, once we have a system, we want to give our users the ability to query the data and visualize it. So different vendors have different products and tools. So in this situation, we will talk about Microsoft Power BI tools and Tableau. Now, the scenario that we have is like a member of the book club will access the book site through the internet. Once they access it and they enter their ratings and their comments, they'll be presented with some books. That then the information will go into the MongoDB database, and then also, of course, the IIS website will have its log, that it logs everything into the weblog about everything that the user did. And that weblog is being monitored by Flume, which will copy the data and stream it into Hbase, which is an online NoSQL database that's highly scalable and very performant. And then we're using the KS indexer service in the Cloudera distribution. As soon as the data hits Hbase, it will also be indexed into SOLR. And then that allows us, now once we have the data in Hbase, and since we defined it in the Hive metastore, we can also use Impala to do near real-time querying of the Hbase table. And And there are other options such as building, like for example, we can create a Python program that will query SOLR through its REST API based on criteria that we have, and then get the row key, and then use that row key to query Hbase through its REST API and get the data that we want. And that is one way of dealing with some of the limitation of Hbase and taking advantage of its performance. So all what you see here on this slide will be all what you see on this slide actually will be part of the presentation on of part 1, and then in the next, as we discussed in the next parts, next episodes, we will be talking about the other sides as we discussed in the previous slide. So now let's go into the demo. Okay, so now we'll have a look at the demo. What you see in front of you are two virtual machines. One is the Windows Server web server that's hosting, basically it's an IIS web server hosting the book club website, and it's an ASP.NET MVC application. And the other one is the CentOS Linux virtual machine that's hosting Cloudera's distribution of Hadoop. Now if we go back into the Windows machine, and what this is here is the web log for IIS. This is the folder, and this is the actual web log. If we double click here, you see that it doesn't have a lot of data because I just accessed the page, but I didn't do anything yet. And this is intentional because I want to show you everything where there is no data, and then as the data gets generated, how things move from one place to the other. And what you see here is actually the a share on the Linux machine, where this weblog will be on a timed basis. It will be copied into that share, and then each copy there will be the differential will be copied on timed basis using a utility called rsync. Probably many of you are familiar with it. I'm gonna put away these virtual machines because we don't need to do things from within the machines themselves, because we can do that remotely using SSH and using the browser interface. So let's start with the browser. Give you a quick tour. This is the website, and it's an ASP.NET application, as I said, an MVC. And I'll come back to it, describe it a little bit more. This is the Hue interface for Hadoop from the Cloudera distribution. And as you can see, it has, this is a Hive UI, this is Impala, Pig, file management, this is Metastore management, Uzi, and then there is this Hbase interface. And within the Hbase interface, we can see the tables, and this is the table that we'll be working with. And as you can see, it's empty, and currently there is only one column family defined. It's info. And I'll come back to that a little bit later, but just want to show you that in the I've already defined, so we have the Hbase table defined in Hbase itself, and I already defined it as an external table in the Hive Metastore using this script. And as you see, these are the columns that will be copying from the weblog, and this is the Seride that does the mapping between the columns in the weblog and Hbase. And this is the Flume service. Within that service, it has an agent, and this is the configuration file for it. And this, what it does is it monitors the weblog file that is on the share, and it copies the data. It streams it into Hbase as immediately as it changes on the file itself. And Flume has as you see here, it has this architecture of sources and channels and sinks. So we are working with the Hbase sync, and you see here there is the regular expression that does the parsing of the columns. And then there is the service of the case indexer. This is the service in the Cloudera distribution, and this is the service that will copy the data, that will do the integration and the synchronization between Hbase and SOLR. And the morph line is a very important part of that, because it defines the columns that will be synced between them. And now there is also an indexer that needs to be posted for that to work. I'm not going to talk a lot about it in this presentation, but I'll make the code available, but I'll talk about it when we have like a more detailed presentation on exactly how everything is done. And this is SOLR, the SOLR administration. And then, for example, if we look here, we have this collection defined for books. And as you see here, there are 0 documents being defined. And then if we looking at the command line, as I said, we can have an SSH session into the Linux machine. And we can start the Hbase shell. And we can see the same things that we saw through the UI. So as you can see here, we have the books app log table, and if we see if there are any data, if there is any data there, so there is no data yet. And then this is so we leave it at that for now. And then we have the MongoDB database, and for example, if we want to see the collections, as you see here, there is no collection yet for book ratings. That collection will be generated automatically as soon as we enter the first rating in the app. And then this is here a folder in the file system. There is a file called a query. It's a Python program that will query the SOLR through its REST API, and based on a specific criteria, and get the row keys that meet that criteria, and then it will query Hbase through the REST API using that row key. So let's have a look at it. So as you see here, the first one is, you see here, query SOLR, and then there is some parsing, and then this is get the Hbase row based on that row key. I'll make that file available as well, but I'm gonna exercise it here during the demo as well towards the end. Okay, so now we have an introduction into what's, the screen gets really busy, as I said. So let's start here with the entering. So this app is just a very simple app to make the, just so we can enter some data. So the idea is that we'll be entering on behalf of these club members, like their ratings and their comments on some of the books. So you have here like 5 users, and then there are these books, and we'll enter the information. So let's say I'm Mike Jones, and I'm a big fan of John Grisham, and I read his latest Sycamore Row, and I really liked it. So I'm gonna give it a rating of 5. So now his best book so far. Now you can tell I've entered I've been running this demo to practice it a little bit earlier. So we'll enter the data. Now the first entry, I had restarted IIS, so the first entry will take a little bit longer. And then now if we want to, you know, for Mike Jones, he wants to enter also his ratings on the Racketeer, and he liked it, but less than that one, and say, I enjoyed reading it. Okay, enter. Notice now that it's much faster. Now let's have a look at another person. Let's say Susan Smith. She is a younger person, female, and she likes Divergent. And so she gives it a very high rating and say, book, enter, see, it went in. And then she also gives Percy Jackson from the Olympians. She will give it an average rating. So, okay, read. Okay, so what do we have here? We're going to look for some interesting words, right? So, and then let's enter some Mr. Peter Sloan. Let's say he entered for the Racketeer, he entered a lowest. He didn't like it. It is quite boring. Right? So here we have entered, you know, like 1, 3, 5, and 4. These are some of the ratings that we have entered. Stopped it. So some of the data should have already been copied right now. And if we look at, let's look at the Hue interface and then look at Hbase and look at books app log. And as you can see here now, there is data. And typically in I'm using the get rather than post, so the data goes here. This is the ratings actually. So some of it you see here, rater ID is 1 and ISBN and book rating of 5. This is the first person, Mike Jones, and this is his best book ever, right? And then if we look at the other one, here is, you know, he gave the Racketeer, a book rating of 4, said I enjoyed reading it, and so on. So this is under the path, right? Now since we defined this table as an external table in the Hive Metastore, which Impala uses, we can query it, right? And so I have a query here that uses regular expressions, and then here it is, and then if I execute it, and here it is. Now this is the delay that you saw really has to do more with the fact that I'm using, you know, 2 virtual machines running on a MacBook Pro. But the fact is, Impala is much faster than Hive, and it's if this was running, if I had run this query in Hive, it will be a map-reduce job, and it will take a lot longer. So these are actually, this is the data that's been entered into Hbase. Actually, it's been queried from Hbase, and we already looked here at Hbase. Now, if we look at the SOLR, and the same thing here, if we now want to refresh, go back and look at core admin. Remember, it was 0. Now I'm gonna look at it again, and as you see now, there are documents. You know, these columns have been indexed into the Hbase into SOLR. So I can look here, and then if I go here to query, and I can do execute query, and you see here there are records. And so what would be, for example, if we look at like the word enjoyed, right? So let's say here path enjoyed. There is. So it is this record that has this row key, right? So we were able actually to index the content of the rating comment, and then look, as you know, Hbase doesn't have a secondary index. So, but with this integration with SOLR, actually we are capable of indexing the content, any columns that we want, and then querying, and then getting the row key, then which we can leverage to get the information that we want from Hbase in a very performant way, very fast. Now we can also look at MongoDB. So we were looking here. Let's look at Hbase itself again. You know, so if we say scan, look at that from the command line, and you see here the data is entered, and then we can see some of the values. Like let's say this one here. See rater ID 3, and saying this is quite boring, right? So that's Hbase from the command line. And then if we look at the MongoDB, remember we were saying that there is book ratings collection is not there yet. So if we do the same command again, and we see book ratings. Now if we want to look at the data for it, then we say and here is the data that went also into MongoDB. So what you have seen so far is we entered data in the web app. It went into MongoDB. This is MongoDB command line. By the way, and this MongoDB is hosted in the cloud. This is it's MongoDB, MongoLab. And if you look here, this is book ratings. This is a UI for it, and then you can query. And here are the same records. So just for those of you who are interested in UI interface for some of these systems and tools. And so we queried, and it went into MongoDB, and also it went into Hbase, as you see here, and as you see here also. And I showed you already that we can query that in Impala, and that how fast Impala is relatively. Basically it's near real time. And then also that it went into SOLR. So now if we want to use that, one way of using that is we can do it like we have a Python. I showed you this Python program. So now if we want to execute this Python script, we can do it this way. And then we pass it the parameters, the first one being the criteria. So C, and let's say we want to say it's book rating comment, the same as what we did in SOLR. And then we pass it the criteria value, CV, and let's say it's the word enjoyed. And then the column that we'll be looking at, which is path. So we make sure we have everything right. Let's try it. And as you see here, it brought first the row key for Hbase, and then it just printed what's in the path. And here is the word enjoyed. You can see it here. And if we do the same, So this is an example really of how it can be used, the combination. I'll go back just to show you this. We were looking here at the same thing. This is actually the output that comes in SOLR, and if we take that and just, this is the same thing that happens in the Python program. It will deal with the script. It will take, one of the things it will do is that it will take away those, right? And then if we take that into so here we are, get books app log, and then the column, and here it is. It's coming back exactly with the same data. So this was the demo. I hope that you found it useful. Okay, I hope that you found this demo useful. That was part 1, and we will talk about part 2 in the next episode and then go from there. Thank you very much.